Okay, so today we're doing the derivative as a function. So there are some rules to note for this section, but also like in the coming lessons and whatnot, we'll get more into in depth about the power rule, quotient, especially the chain rule and the product rule as well. So first of all, the power rule, a lot of you should be familiar with it. So it's basically when you take the exponent and you bring it to the front and you subtract the exponent by 1. So, for example, if I'm taking derivative of x cubed, what I would do is I'll take the 3 to the front and then subtract 3 minus 1. So I would be left with 3x to the second power. And we also need to be familiar with what derivative graphs look like the f prime graph of fx. And we'll get a little into that through the questions. And we're going to need to know the product rule, which is basically f times g prime plus f prime times g. And then the quotient rule is f prime times g minus f times g prime over g squared. Now, these, you'll have them memorized once, through practice. So you don't really need to worry about that. And then the chain rule is f prime in parentheses g times g prime. And this as well, you'll have that memorized through practice. All right, so let's get on to the first question. So we're going to be basing all of our answers over this graph right here. So all these questions are asking us about the derivative at a certain x point. And this is the position, or rather the first, the fx graph. So A is asking us to find f prime at 0. So 0 is right here. And we could see at 0, the graph is increasing slightly. We could probably give it a slope of 0.5 or 1/2. And then at f prime 1, so that's right here, the slope, we can see it kind of levels out. That's it's the difference between when it's increasing and decreasing. So we could say this like the instant slope right there is very likely just 0 because it's kind of flat at x equals 1. Now C is asking us f prime of 2, which is over here, and f prime of 2, we could see the graph starts decreasing a bit at a pretty good slope, so we could probably estimate that as -1 as it's decreasing, but not by like a huge factor. And now D is f prime of 3. So at x equals 3, we can see the graph is starting to really decrease, pick up pace. And we could kind of actually estimate it as well. We could see it's going through down more than one box, so we could estimate it at like 1.5. So that'll be -1.5 or -3/2. That's the slope for that x value. So E is asking us f prime of 4. So at 4 is right here. And we could kind of see that it's the slope is kind of like evening out here. So if it is still negative, so it's just a smaller negative number. So we could kind of estimate that to be about -1 slope. And then f prime of 5, which is right here. This is a similar scenario to f prime of 1, in which the tangent line is like just horizontal, which means that the slope is 0. And then f prime of 6, we can see it starts increasing a bit, the graph, at a pretty good slope, so we could estimate that to be 1. And then f prime of 7 right here, we can see that the graph starts picking up some real increasing slope. So we could probably estimate that at probably also 1, but f prime of 7, as I'm seeing it, would be less than f prime of 6. You see this is curving up, and then once it gets to 7, it's curving down, so that means it's slowing down. Alright, so let's try this question. This question is going to be like a good type of explanation to derivative graphs and how to identify them. So number 12 is shown is the graph of the population of function pt for yeast cells in a laboratory culture. Use the method of example 1 to graph the derivative of p prime t. What does the graph of p prime tell us about yeast population? So we can answer this second question right here. So the p prime would tell us how fast. So we talked about the position and then the velocity. So the velocity is the derivative of the position function. Now we're talking about population here. So uh, like on a counter scale, the derivative of the population graph would give us how fast the population is growing. Or you could also put it in words, maybe the velocity of the population growth, if that makes sense. Population is growing. So that it tells us the graph of p prime will tell us how fast the population is growing of yeast cells. And we want to use the method of example 1 to graph the derivative of p prime. So we could try that. So we're going to do like a ballpark kind of estimate for the graph, the prime graph, as long as we get, the direction, the slopes correct. So we could see from the interval of 0 through 5, the slope is positive, but it's increasing. The slope could start right here. And we could first, let's examine this whole graph actually. So we can see it increases and then it kind of stables out at like a pretty high slope. And then it goes back down, it evens out, which means the slope is going closer to 0. So it goes from 0 to a high positive number back down to 0. So the graph of the derivative would look something like this. And then the y value of the slope isn't really necessary here, but the important part is understanding why the derivative graph is peaking like that and then is going back down. Because basically, if you add up all the tangent lines, you could the graph is a lot more explainable. So a tangent line here is horizontal, which means that it should be a 0 here, the velocity or slope of how fast the population is growing. And then over here, it's like, a number, but it's increasing. It's a high positive number. Here's the high positive number it peaks at. And then it goes back to a horizontal tangent line, which means at 0. And then here it goes back to 0. All right, so now we're going to try these 4 questions. So what we're just going to be doing is just finding the derivative of this, the equation of the derivative. So let's see, f prime, and f prime. So we could see that these do involve some like important rules that we need to know. So f prime or the derivative of sine of x is cosine of x. So the answer to that would be cosine x. And always remember the derivative of cosine of x is negative sine x. And then for 17, fx equals e to the power of x. The derivative of ex is always ex. Because if you look at the ex graph, it is increasing in a way that if you were to find the slope and like the tangent lines and graph the tangent lines, it would just be the same exact graph. So you could try that out, but remember that the derivative of ex is always ex. And now we move on to number 18. So for this, always remember rule of thumb, the derivative of ln of x is always it's 1 over what's inside the parentheses x, multiplied by the derivative of what's in the parentheses. So in this case, it would be 1. So let's try a mock real quick. So let's say ln of 5x cubed. So derivative of this would be 1 over 5x cubed multiplied by 15x squared. You could also move the 15x squared to a numerator here and simplify, which would give you 3 over x, right? Yeah, 3 over x, that would be your answer to ln 5x cubed. Now for this ln of x, that would just be 1 over x. And then the final one, f of x equals x squared. The derivative, as we talked about before, is just 2x. So that is basically your answers for all of those, and especially ln x, ex, and the sine function. These require just memorizing the answer or knowing the rule behind it. And this you could just use the power rule. Alright, so I want you guys to take a minute and try number 2, so you could pause the video and try it out. Alright, so we can see number 2 is it's giving us a graph of fx, and we're having to find f prime. So basically we're having to find the slope or the tangent line at that given x value. So let's take a look at f prime of -3. So -3 would be right over here. So we can see a tangent line is, it's like decreasing, so it's definitely a negative number. We could probably estimate it to -1, and f of -2 is right here. If we draw a tangent line, we can see that it's flat. So that means that f prime of -2 is 0. Now f prime of -1 is, now the graph is starting to increase. So we know it's a positive number. It is increasing at a decent rate, so we could say that f prime of -1 is 1, and f prime of 0. So the tangent line at 0, we could see is it's quite a large positive number. So because it's increasing, so we could just estimate it to be 2. And then f prime of 1, 1 is right here. If we draw a tangent line, we could see it's increasing a little bit more than f prime of 0, so we could estimate that as 2.5 or even 3. And f prime of 2, we could see that the graph kind of just flatlines here. So if we draw a tangent line at f prime of 2 for x equals 2, we get a horizontal line, which implies that the slope at f prime of 2 is 0. And now f prime of 3, the x value of 3, if we draw a tangent line, we get a negative slope, as we could see. We could probably infer that the slope is probably -1. So the important thing with these questions is as long as you signal whether it's a decreasing or increasing slope or a slope of 0, you'll most likely get the right answer, as it's not exactly possible to tell exactly what slope it is, but estimations work just fine. Alright, so this is number 13, so I want you guys to try this out on your own, so you can pause the video and try it out. Alright, so 13 is a rechargeable battery is plugged into a charger. The graph shows CT, the percentage of full capacity when the battery reaches us as a function of time is elapsed in hours. What is the meaning of the derivative C prime function t? So if this is the graph of CT and it's how much, like the percentage of the battery, the graph of CT should tell us essentially the velocity, which in this case we would word it as how fast it is charging at a given moment. How fast it is charging. Or you could also say, charging velocity, even though that doesn't make sense, but always relate velocity to the prime function in terms of position. So you can always, visualize what the prime function is going to be and what it means. So B is telling us sketch the graph of C prime T. What does the graph tell you? So if we just create a mock graph here, 2, 4, 6, 8, 10, 12, and we don't need to really specify any slopes as long as we get it the curvature of the graph mostly correct. So we can see at the beginning, the slope of the graph is the most at the beginning. It's a really big positive number. And then the slope kind of like decreases. And now here we can see the slope is a horizontal line, which means it's 0. So we could kind of just point some dots real quick. So at 12, we kind of know the slope is 0 because of that horizontal tangent line. And at the beginning, we kind of estimate the slope would be somewhere up here. And since this line it's flatlining at like a steady pace, we could show that the derivative graph, as in the how fast it's charging, is slowing down at a pretty constant pace. So as time has gone through by hours, although the percentage battery has increased at a slower pace, that means that the velocity, how fast it is charging, is decreasing. So as time has gone on, the phone started charging at a slower rate, but it is still charging. So that's what we can deduct from the first derivative function. And yeah. Alright, so I want you guys to try all these questions, these 8 questions, so you could pause the video and try them out. This is gonna involve some power rule, quotient rule right here. I don't believe any product rule, but maybe a chain rule in there as well. That's it. Alright, so let's take a look at number 1. Number 1 is function x equals 3x minus 8. So that's the function we want to find f prime of x, which is equal to just 3. Because if x goes down in power, it becomes 0, and then all constants cancel out. And now 22 is f of x equals mx plus b. Now this is like the same thing, except so if we function prime f prime of x, so for all of these we're finding, or at least 21 and 22, we're finding the derivative respect to y. So if the function has d over dx, it means that you're going to find the derivative in terms of y, or respect to y. So we find it in respect to y. This x goes to a power of 0, which means it becomes 1. And then b is a constant, so it crosses out, just like what happened up here. M is the slope, or the coefficient of x, in which m stays. So f prime of x is m. Now 23, f, the function t, is 2.5 t squared plus 6t. So for this, we could just use the power rule. If we put t in the front, we get 2.5 times 2, which is 5, and then t. And plus 6t, we could just cancel out the t. That would be 5t plus 6. Now 24 is f of x, 4 plus x, 8x minus 5x squared. So for this, we could just use a power rule. Constant canceled out, x becomes 0, so we get 8, and then 2 goes multiplies by 5, and then this turns into 1, so we get minus 10x. That would be your answer. Let me circle these. And now AP equals 4p cubed plus 3p. So for this, we can just use the power rule. 3 multiplies to 4, so we get 12p squared plus 3p cancels out, so 3. And then for 26, we could also use the power rule. 3 goes in the front, so we get 3t squared plus 5. T cancels out, and the constant cancels out. Now 27, we are going to have to use the quotient rule, which, if you remember, it's f prime times g minus f times g prime over g squared. So if we use that rule, so f is the top function and then g is the bottom function. This is equal to f of x over g of x. Like that's what you base the rule off of. So the derivative of 1 is 0, so we could do 0 and then g times g, which is x squared minus 4, and minus f, which is 1 times g primes, which is 2x. And in the denominator, we're going to have x squared minus 4 squared, which if we just simplify that, that would give us x to the 4th power minus 8x squared plus 16. So if we simplify all of this, we would get negative 2x over x to the 4th power minus 8x squared plus 16. So that will be your final answer for that. You could also you could leave it in x squared minus 4 squared like the form, but you could also simplify it. Doesn't really matter how you set up your answer. Now this one we also got to use the quotient rule, number 8, f of v. So we'll do the same thing we did for 27. So f of prime is 1, which is v, and then times g, which is v plus 2, minus f is v times g prime, which is 1. And then on the bottom, we're going to have v plus 2 squared. So if we simplify all that, we would get v plus 2 minus v on the top. And on the bottom, we would get v squared 4v plus 4. And the v's would cancel out, so that would be your final answer would be 2 over v squared plus 4v plus 4. And yeah, that's your final answer. So I hope you guys understood how how to visualize a derivative graph and a derivative as a whole. Always remember like the position velocity kind of rule, and some rules we went over that you're gonna go more into deep on later on is the quotient rule we did, the chain rule, and the product rule we didn't really get to. But it is also really important to know how to draw a derivative graph based on just a function graph, and as well as understanding the slopes and tangent lines and what they mean. So yeah, that's basically it.